Thank you very much, Francesco, for this thorough introduction. And I'm really pleased to be here today with you and deep dive on sustainability credentials of copper. Electrification, that's a word we hear nearly every day in our life, and this is one of the mega trends which drives different sectors, HVAC sector among others. Why is that? Because electrification is clearly the most energy efficient way of decarbonization of different sectors, among others heating and cooling of buildings. And this electrification, for this electrification, we will definitely need more copper. Why is that? Primarily because of its electrical and thermal conductivity. Electrical goes without saying in case of electrification, and if we would organize an Olympics of different metals in electrical and thermal conductivity, first place and gold medal will go to silver. Silver medal will go to copper, and surprisingly, the bronze medal will go to gold. So this is a kind of ranking in conductivity. And as you can see, aluminium is at around 60% of both electrical and thermal conductivity of that of copper. In addition to conductivity issues, there are some other properties like high corrosion resistance, machinability, bending and brazing, and sustainability with focus on circularity of the material. Talking about thermal applications, the product used in thermal applications or in heat exchangers is copper tubes. And fabrication of copper tubes is very well established in Europe with a long decades of history. Capacity is here. At the moment, we even have a kind of spare capacity to produce high-quality copper tubes for heat exchangers in Europe. Talking about sustainability, tubing is one of the applications with a very good potential for using recycled material. And carbon footprint of European tubes is continuously improved, and this will contribute to better life cycle data of equipment's final products. We have a global copper tube average CO2 embodied emissions is 2.7, bit higher, and a European best example is 0.5 kilograms of CO2 equivalent per copper tube. The HVAC equipment of the future should be more energy efficient, should be smaller, should be mass produced, and last but not least, ready for new refrigerants according to new regulations. And this is exactly what an innovative small diameter inner groove copper tube can provide for different air to refrigerant to air heat exchanger applications, whether it's evaporator, condenser, or gas cooler. So that is basically where copper is mainly used in heating application. Talking about copper as a raw material, we can say that in the EU, smelting, refining, and recycling is mostly met by within EU, so by domestic capacities. Basically, we have two legs of copper production. First is mining, primary, and the second one is recycling or the secondary. So if we have at the big picture, have a look at the big picture in Europe, we use 4.5 million tons, and it's growing. 20% of this is extracted, that means mined and fully processed until refined stage. Another 20% is refined and smelted in Europe, but from imported concentrate. Concentrate is the, let's call it, end product of mining with around 30% of copper content. 50% of this is recycled, whether it's direct melt or end-of-life scrap. 50% is from recycling sources, and only 10% of the European refined copper demand is imported. Ace showed this and asked the question, who has seen this raw material assessment made by the European Commission in 2023. Basically, they have a look at two dimensions, or I would like to show this to you, a supply risk threshold and economic importance threshold. Yeah? So basically, you can see copper is below supply risk threshold in Europe, but is above the economic importance threshold. What does it mean? That copper is a strategic material, but its supply, it's not critical because it's very well diversified in Europe. Critical Raw Material Act has established a kind of 2030 targets for self-sufficiency, of different materials, and they have different targets for different stages of the material processing, from extraction to a single country dependency. And you can see that copper in 2020 already was above all of these targets for 2030. Extraction mining is 50%, and dependency of a single country, you can see that mining is mostly done in Poland and refining in Germany. If you compare it to aluminium, you see that extraction is just 1% above the 2030 targets. And interesting is also the mining dependency on a single country, which is 63% dependency on Guinea. A next question, what we often get, that do we have enough copper? So here on this chart you see two bars. Yellow bar is a mine production in million tons in given year, and the green one are reserves. Reserves are proven reserves which can be, extracted. So in 2023, copper mining was around 21 million tons, and reserves are 1 billion tons. So that means that according to this study, we have enough copper reserves for 45 years. The good news is that since 1950, this has always been around average of 40 years. Okay, we need more copper, but it's not enough. We need more and better copper. That's why ICA members are committed to increase capacity in sustainable way regarding mining. What does this mean? Bring Scope 1 and Scope 2 GHG emissions to net zero by 2050. And in addition to this, different stakeholders in the value chain introduce the copper mark, which is a leading assurance framework to promote responsible practices across the industry. And this assurance framework goes well beyond the GHG emissions for other environmental and social aspects. So that was about mining. What about recycling? I can say that this is the area where copper really shines. First of all, it can be repeatedly recycled without loss of properties, but recycling will not suffice. We need mining and recycling and trade to secure growing demand. Priority for recycling should be the design for recyclability and end-of-life recycling. That means every atom should be collected and recycled for a new use. And we should avoid the pitfall of recycled content requirement in case of metals such as copper. Our good news is that our society holds a massive so-called urban mine of copper. Since the beginning of last century, we have mined about 690 million tons of copper, and around 2/3 of this is still in use, can be recycled. How recycling is done? The recycling routes basically depends on a scrap purity. Here you can see the process of copper refining from 30%, which is a concentrate, coming from mining to refined 99.99% copper. So if you have a pure scrap, it can go to so-called direct melt. If you have a scrap of lower quality or copper alloy, it have to go earlier into this refining process. Why is this important? Because if you have a pure copper, you will have around 85% of emission and energy savings compared with virgin material. The less copper content, the less energy saving and emission saving in this process. But very important is that end result is always a pure 99.99% copper, whatever the scrap quality is at the beginning. We have some limitations in availability of secondary material. And basically there are two big limitations. The historically growing demand, that copper demand, global demand, roughly doubles every 25 years. And average lifetime in use of copper products is also around 25-30 years. That means that inflow of new material into the stock is always higher than outflow for recycling. Here you can see it maybe a bit better. This is the refined copper usage from 1900. So let's take an average 25 years of lifetime. From 2023, in 2023, we used 26 million tons of copper. Yeah? If we go back to what we want recycled, that means 25 years, yeah, the copper installed or put in service, that time it was only 13 million tons. So 1/2 of the current demand. So if we are perfect and 100% efficiency in recycling, we can theoretically have half of current demand by recycled. But of course, it will never be 100% because some of the material is lost, etc. So theoretical recycled content at global level is around, let's say, 35%. So that's why recycled content, high recycled content requirement will not work for metals. Can one company have 100% recycled copper in their product? Yes. 5 companies? Yes. Every company globally? No, it's impossible because of this. So what we can do to make more scrap available? We talked about it today, design for sustainability. to make it easier to happen, incentives to improve collection rates, and once it's collected, some trained artificial intelligence system, innovative shredding may also help us. What is decreasing the scrap availability? Complexity of product. If you have a more complex, the metal is more dispersed in the system, it's more complicated to collect at the end of the life cycle. And also the policies requiring longer lifetimes makes less material available for recycling. It's good for consumers, but from recycling point of view, it's unfortunately negative. So, to wrap up my presentation, copper is a strategic material, but it's critical because it's not critical because the supply is very well diversified in EU. We have two legs of copper production. Primary production from mining is on the path to net zero, and the material is strongly recyclable. It can be recycled again and again with the same, exactly the same quality as mining, but recycling will not be enough for cover future demand. Therefore, to securing EU's copper supply in the future, we need to boost mining, refining, recycling, and global trade partnerships. Thank you very much for your attention.